Good afternoon, students. In this class, we are going to discuss about the next concept in the same unit, that is P block elements. The next concept is chemical properties of 13th group elements. Chemical properties of 13th group elements. We will discuss this concept in this video. In my last video, we have completed the general properties of 13th group elements and also the physical properties of the 13th group elements. Now we will go for the chemical properties of the 13th group elements. Before going to the chemical properties of the 13th group elements, first we will discuss the oxidation state. Here it is. First we will discuss the oxidation state and trends in chemical reactivity. Trends in chemical reactivity. We will discuss first this one. Now, already we know that the elements of 13th group are, what are the elements of 13th group? Boron, aluminium, gallium, indium, and the thallium. These are the elements of the 13th group. Now, here, boron and aluminium, these two, will show only +3 oxidation state. Boron and aluminium shows only +3 oxidation state. Whereas this gallium, indium, and thallium, these gallium, indium, thallium, these three can show +3 oxidation state and also +1 oxidation state. Means gallium, indium, thallium are showing 2 oxidation state. What are those? +3 oxidation state and also +1 oxidation state. Here +3 oxidation state and also the +1 oxidation state. Now the question is, why this gallium, indium, and thallium are showing both +3 and +1 oxidation state? Or we will see why this boron, aluminium are showing the +3 oxidation state, why gallium, indium, and thallium are showing both +3 and +1 oxidation state. For this one, I will take the rough paper first here. Now just check, I will write the elements. What are the elements? Boron, aluminium, gallium, indium, and the last one is thallium. These are the elements of which group? 13th group. If you see the electronic configuration, atomic number of boron is 5, here aluminium is 13, gallium is 31, and the indium is 49, and the atomic number of thallium is 81. Elements, atomic number, I wrote atomic number Z, right? Now we will see the electronic configuration. If you see the electronic configuration of boron, here it is helium 2s2 2p1. If you see the electronic configuration of aluminium, that is neon 3s2 3p1. If you see the electronic configuration of gallium, that is argon 3d10 4s2 4p1. If you see the electronic configuration of indium, krypton 4d10 5s2 5p1. If you see the electronic configuration of the thallium, that is xenon 4f14 5d10 6s2 and 6p1. These are the electronic configuration of the 13th group elements. Already we have discussed it in the first video only. This over. Now here it is required for reasons. We are seeing these electronic configuration of the 13th group elements because I want to tell why these all elements are showing +3 oxidation state and also this gallium, indium, and thallium showing +1 oxidation state. For this reason, I am taking the electronic configuration. If you check the number of valence electrons, here it is 3 valence electrons, 3 valence electrons, 3 valence electrons, 3 valence electrons, and 3 valence electrons. All are having 3 valence electrons. Means in the last shell of each atom of boron, aluminium, gallium, indium, and thallium, these are having 3 valence electrons, right? Means in the last shell of these atoms they are having only 3 electrons. Only how many electrons? 3 electrons. That is called as what? 3 valence electrons all these are having. If all these are losing 3 valence electrons, if they lose all the 3 valence electrons, then the oxidation state is +3. Means all are having 3 valence electrons. If they lose all the 3 valence electrons, or when they form all 3 bonds, then the oxidation state is +3. Oxidation state is +3. Now why these 3? Gallium, indium and thallium. Why these 3? Gallium, indium and thallium are showing +1 oxidation state. For these 3 only, na? For gallium, indium and thallium, these showing +1 oxidation state. Why? This reason I will tell only in one word, that is inert pair effect. Why these 3 are showing the +1 oxidation state? Here I wrote gallium, indium, thallium shows the +1 oxidation state only. Why these 3 are showing the +1 oxidation state? Then the answer is only inert pair effect. Sir, what is meant by inert pair effect? There the question is there again. What is meant by inert pair effect, sir? For this one, I will just tell. Now just check here. 4s2 4p1 in the gallium. 4s2 4p1. Just observe this one. Valence electrons 4s2 4p1. Right here I will write with green pen. Now in the indium also 5s2 5p1. In the thallium also 6s2 6p1. Here what happens in these atoms or in these elements, gallium, indium, thallium, only when p orbitals are forming the bond, means only bonding is possible only for the p orbitals, means s orbitals are not involved in the bonding. P orbitals are forming only bonds, s are not involved in the bonding. Only p orbitals, that is the electrons which are present in the p orbitals, are forming the bonds, whereas the electrons which are present in the s orbital are not forming the bonds. Now just I want to write in simply 4s2 4p1, 5s2 5p1, 6s2 6p1 as ns2 np1 for only gallium, indium and thallium. Here only p electron is involved in the bonding. P electron is involved in the bonding, whereas these s electrons are not involved in the bonding. Means here only p electrons involved in the bonding, means only one electron is involved in the bonding, therefore the oxidation state is +1. Whereas these two are not involved in the bonding. Why they are not involved in the bonding? Right, because of higher stability. Now just check here why it is called inert pair effect, because here s electrons and s electrons, right, paired electrons, 2 electrons are there, paired electrons which are not involved in the bonding, therefore it is called inert pair effect. Means what is meant by inert pair effect? Only p electrons are involved in the bonding, whereas the s electrons are not involved in the bonding, is called as what? Inert pair effect. In simply I can say, in the valence shell of an atom, maybe gallium, indium, thallium, only p electrons are involved in the bonding. Only p electrons are involved in the bonding, not the s electrons. That effect is called as what? Inert pair effect. Because of that effect, the oxidation state of gallium, indium and thallium is +1. Clear? Now that is only I will write here. Question: why gallium, indium and thallium shows +1 oxidation state? Question. Right, now here +3 oxidation state because valence electrons are 3. If they are loose or if they can form the bond, then the oxidation state is +3. Now answer for this one is here inert pair effect. Your answer should be in one word, that is inert pair effect. What is meant by inert pair effect? Definition I will tell here. Only in bracket I will write the definition for the inert pair effect. Right, what is meant by inert pair effect is, in the valence shell, means the last shell of an atom, maybe gallium, indium, thallium, only the which electrons are involved in the bonding? Only the p electrons are involved in bonding. not the s electrons, not the s electrons, bracket the paired, is called inert pair effect. This is the definition for the inert pair effect. Here it is, definition for the inert pair effect. Means if the general valential electronic configuration is ns2 np1, it is for 13th group, and here it is for gallium, indium and thallium, right? Only p electrons are involved in the bonding, right? Here it is involved in bonding, whereas these s electrons, here it is, these s electrons not involved in bonding, not involved in bonding. This effect is called as what? Inert pair effect. Now what is the stability, sir? Right, +1 oxidation state stability, sir. I will write here order of stability for +1 oxidation state is right. Now gallium +1 oxidation state compounds are least stable than the indium +1 oxidation state compounds than the thallium. Means the compounds of thallium where it is having +1 oxidation state is more stable than the compounds of indium where the oxidation state of indium is +1, and the compounds of the gallium where the oxidation state of the gallium is +1. Means thallium is more stable in +1 oxidation state and gallium is the least stable in the +1 oxidation state, right? This is the order. This is the order of stability of +1 oxidation state. Now here next we will go for the another point I want to discuss here. For this one I took blue pen, just another point. What is that one is here BCl3, BF3, AlCl3 are Lewis acids. Now here I will take why they are Lewis acids. For this one, for this reason, I will take one rough paper first. Now just remember 13th group elements BCl3, BF3, AlCl3, right, are Lewis acids. Oh, here if you see the BCl3, if you see the BF3, if you see the AlCl3, in all these compounds, here in boron it is surrounded by 6 valence electrons. Here also in the compound BF3, the boron is surrounded by the 6 valence electron. In the compound AlCl3 also the aluminium is surrounded by the 6 valence electron. Already we know the octet rule or Lewis dot structure, right? The atom which is surrounded by the 8 valence electrons in the compound is more stable. Correct? What is octet rule? The capacity of the atom to achieve how many valence electrons? 8 electrons in the valence shell, right, is more stable. That is called octet rule. For here 8 valence electrons are required for the more stability. But BaCl3 is having, in the BCl3 the boron is having how many valence electrons? Only 6. In the BF3 the boron is having how many valence electrons? Only 6. In AlCl3 also the aluminium is surrounded by how many valence electrons? 6. Means how many still electrons are required? Still how many electrons are required for these compounds to become stable? 2 valence electrons are required. Means 2 electrons are required for the boron in the BCl3. Again 2 electrons are required for the boron in the BF3, and the 2 electrons are required for the AlCl3 in the compound. Means they are ready to accept the 2 electrons. They are ready to accept lone pair of electrons. Correct? Because these are not having 8 electrons in the valence shell. Therefore the electrons which are present around the boron, aluminium in their compounds is less than 8. 6 electrons means less than 8, 8 valence electron means more stable. Here these are having how many valence electrons? 6 means how many electrons are required? Still 2. Therefore they are ready to accept the lone pair, that is 2 electrons, right? The one which accept the lone pair, that is called as what? Lewis acid. What is meant by Lewis acid? The one which accept the lone pair of electrons is called as what? Lewis acid. Because here in these all compounds, the central atom, that is boron or aluminium, these are having less number of electrons. Therefore, they are ready to accept the lone pair of electrons. When they are ready to accept the lone pair of electrons, those are called as what? Lewis acids. Now I will write here because the compounds here, because they ready to accept the lone pair of electrons, they are Lewis acids. They are Lewis acids. Right. Now, for satisfying octet rule, sir, what they will do? BSCl3, what it will do? AlCl3, what will we do? For satisfying what? Octet rule. For satisfying what? Octet rule. For this one, I will take another paper. Here it is. To achieving 8 electrons, PCl3. In the BCl3, boron is having how many electrons? 6. Here also boron is having how many valence electrons? 6. In the AlCl3 also having how many valence electrons? 6. Means still how many electrons are required? 2. For achieving those 2 electrons, sir, PCl3 what it will do? BF3 what it will do? Now we will see. Right. I told already Lewis acids means they accept the lone pair of electrons. That is only I am drawing. Now just check here. I took BCl3. B, Cl, Cl, another Cl. BCl3 na? BCl3. When it react with the base, that is NH3 base, nitrogen is having lone pair of electron on it. One lone pair of electron on nitrogen is there. Right. Now just check here. Now one lone pair of electron on the nitrogen. Boron, Lewis acid or Lewis base here, BCl3 in the right. Boron, it is ready to accept the lone pair of electrons, means Lewis acid. It will accept the lone pair of electrons from the nitrogen. Therefore, it will become BCl, Cl, Cl, and here it is NH3 plus because it is accepting the lone pair, right? It is losing the lone pair of electrons, right? This compound is formed. In this way, they will become the stable. They will become the stable. Now, if you check the valence electrons, 2, 2, 4, 6, 8. Now it is having how many valence electrons? 8. Already 6 are there. If I take one lone pair of electrons, 2 electrons, right? Now how many valence electrons are there? Now 8. Now it is stable. Now here, then how AlCl3 will get stabilized, sir? Right? AlCl3 achieve stability by forming a dimer. Dimer means 2 monomer. 1 monomer, 2 monomer means dimer, 3 monomer is trimer. Many monomers are there in the compound, means that is polymer. Poly means many monomers means polymer, right? Here it is forming dimer. Dimer means 2 AlCl3 will form the compound, that is called dimer. How it will form, we will see. Now just check here. I will write AlCl, Cl, Cl. One AlCl3 na. Now I will write another AlCl3 here. AlCl, Cl, Cl. Right? 2 AlCl3 na. Just check here. One AlCl3, another AlCl3. How they will form dimer, sir? Right? A partial here bond is formed. Here also another bond is formed. Right? Now bridge structure. Which structure it is? Bridge structure. And this Cl are called bridge chlorine atoms. Bridge chlorine atoms. Now it is dimera or trimera? 2 AlCl3 are there, 3 AlCl3 are there, 2. Therefore, what is the structure? It is dimer structure. If you count the number of valence electrons around the aluminium and aluminium, it will be 8. How, sir? Just check here. One bond means 2 electrons. 2, 2, 4. Here it is 6. Here it is 8. Now here also 2, 4, 5, 6, 7, 8. Means it is also surrounded by the 8 valence electrons. This aluminium is also surrounded by the 8 valence electrons. Right? Means it will get the stability by forming the dimer structure. By forming which structure? Dimer structure. Right? Now we will go for the reaction of 13th group elements. Reaction of 13th group elements. with air and nitrogen first. Next we will go for the reaction with acids and alkalis. Next we will discuss the reaction of 13th group elements with the halogens. 3 we will see. What are those? A reaction of 13th group elements with air and nitrogen first we will discuss. Next we will go for the reaction of 13th group elements with acids and alkalis, means acids and bases. Alkalis means bases. Last one we will go for the reaction of 13th group elements with halogens. These 3 we will discuss how they will react and what are the compounds formed in the reaction. We will discuss now. Right, for this one, first we will take first one by one we will discuss. First one we will discuss the reaction of 13th group elements with air and nitrogen. First we will discuss this one. Now here it is for this one. Now just check here, boron and aluminium. What are the 13th group elements? Boron, aluminium, gallium, indium, thallium. These are the 13th group elements. Correct? Now just to check here, boron, when it is present in the crystalline form means the particles or the constituent atoms are arranged regularly. Means when they are present in the crystalline form is not reactive, means unreactive. Boron is unreactive with the air and nitrogen. In amorphous form, when the constant particles are not arranged regularly, means irregular arrangement of the constant particles, in such cases the boron is reactive. With air and nitrogen. Means just remember, when boron is present in the crystalline form, no reaction. When boron is present in the amorphous form, there is a reaction. When this boron reacts with air, right, amorphous boron, when it is reacting with the air while heating, it will form boron trioxide. Here it is, the compound formula is B2O3, it will form. And when this boron reacts with the nitrogen, amorphous boron, not crystalline is unreactive. When this boron react with the nitrogen while heating, it will form boron nitride, that is Bn. Here it is called as what? Boron nitride. Right. Similarly for aluminium also, we will go for the aluminium. Now similarly for aluminium, what happens here? I will take one rough paper. Here, if this one is the aluminium, its surface is already reacting with the air. The surface of the aluminium is already reacted with the air, and it will form a thin layer of its oxide, means aluminium oxide. Thin layer of the aluminium oxide. Therefore, almost all it is unreactive now, least reactive, because its surface is already reacted with the air and it is formed the corresponding oxide, that is aluminium oxide. Means the layer which is present on the aluminium, right, which act as a protecting layer, means when aluminium comes in contact with the air, its surface is covered by the corresponding oxide, that is aluminium oxide. Thin film is formed on the surface. Therefore, it is least reactive towards the air and nitrogen, right? That is only I am writing here. When this aluminium forms thin oxide film on its surface, now it is unreactive. Why it unreactive? Already I told, its surface is already covered by the corresponding oxide layer. It acts as a protecting layer, right? Therefore, it is unreactive. But in amorphous form, that is in powder form, again it is reactive. reactive. Right, here also when this aluminium reacts with air while heating, it will form aluminium oxide, that is Al2O3. Aluminium oxide, that is what? Al2O3. And this aluminium when reacts with the nitrogen, it will form the corresponding nitride, that is aluminium nitride. In this way the reaction will take place for boron and aluminium, only for boron and aluminium. For other compounds, sir, what happens? For this one I will take another paper here. For other elements, sir, right, boron, aluminium, okay. Sir, what about gallium, indium, thallium, sir? Right, for this one we will take here this paper I am using here. Now just check here for this one. Other elements, if I write generally, here it is, I will write generally. For other elements, if I take E means what? Element, maybe gallium, indium, thallium, reacts with air, that is O2, they will form the corresponding oxide, that is E2O3, corresponding oxide. That E is any element, right? Now gallium, indium, thallium, right? Now just check, it is unbalanced. For balancing I am taking 4 moles of E. Here it is. Here it is not focusing. Wait a minute. Now here for balancing 4 moles of E reacts with 3 moles of O2. While heating it will give 2 moles of corresponding oxide. E means 13th group elements, just you have to remember. And when 2 moles of E reacts with the nitrogen while heating, it will form the corresponding nitride. This is the general reaction of 13th group elements. Here E means 13th group element. When this 13th group elements reacts with air, it will form corresponding oxide. When this 13th group elements reacts with the nitrogen, it will form corresponding nitride. Corresponding oxide, corresponding nitride are formed when 13th group elements reacts with the oxygen and nitrogen. This was right reaction. Now we will see the properties. Just check here. I want to write here general characteristic properties. Right? General properties of oxides of 13th group elements. Right, now I will write, when boron reacts with oxygen, it will form boron oxide. Right, when aluminium reacts with the oxygen, it will form aluminium oxide. When gallium reacts with the oxide, gallium oxide. When indium reacts with the oxygen, it will form indium oxide. Here, when thallium reacts with the oxide, it will form thallium oxide. Here it is. When boron reacts with the oxygen, it will form boron oxide. When aluminium reacts with the oxygen, it will form aluminium oxide. When gallium reacts with the oxygen, it will form gallium oxide. Next, when indium reacts with the oxygen, it will form indium oxide. When thallium reacts with the oxygen, it will form thallium oxide. In this way. Now just check here. Here this boron oxide is acidic in nature. If you check the nature, it is acidic in nature. Means it can react with the bases. This boron oxide can react with the bases, not with the acid. Means boron oxide is acidic in nature. For reaction, acids reacts with the bases. Acid, no reaction. Acid react with the base or base react with the acid. If one which reacts with acid as well as base is called as what? Amphoteric nature. For this one I will take rough paper. Now check. Acid reacts with base. The reaction is possible. And base can react with the acid. The reaction is possible. Acid, no reaction. Base, no reaction. The one which reacts with both acid and also both base, both acid and base. The one which reacts with both acid as well as base is called amphoteric is called which nature? Amphoteric nature. What is made of amphoteric nature? The one which acts as acid as well as base. That is the one which can react with the acid and also with the base is called amphoteric nature. Here, this boron oxide reacts with only base. Boron oxide reacts with only base. Means what is the nature? Acidic nature. Acidic in nature. If you take this one, aluminium and gallium oxide. Aluminium and gallium oxide. Aluminium oxide reacts with the base. Aluminium oxide reacts with the acid. Okay? Both aluminium oxide is reacting with the base and also reacting with the acid. Similarly, gallium oxide can also react with the base and acid. Means which nature it is? Aluminium oxide and gallium oxide can react with both acid as well as base. Both acid as well as base. Means which nature it is? Which nature? Amphoteric in nature. Amphoteric in nature. Boron oxide is acidic in nature. Aluminium oxide, gallium oxides are amphoteric in nature. And this indium and thallium oxide. Indium and thallium oxides can react with only acids. Right? Indium oxide and thallium oxide, they only react with the acids. They only react with the acids. With bases, no reaction. With bases, no reaction. These indium oxide and also thallium oxide. Indium oxide and thallium oxide reacts with only acids and they are not reacting with bases. Means what is the nature? Basic in nature. These are which nature now? Basic in nature. Means these are reacting with acids, means these should be bases. Right? Therefore, I can write here these two are basic in nature. Basic in nature means boron oxide is acidic in nature. Aluminium oxide, gallium oxides are amphoteric in nature. Indium oxide and thallium oxides are basic in nature. Right? These are the few general characteristic properties of the oxides of 13th group elements. Right? Just remember, first one is acidic, next two are amphoteric, and the last two are basic in nature. Next, we will go for the reactivity with the acids and alkalis. Reactivity with what? Acids and alkalis. Now, second reaction we will see. Second one is reaction with acids and alkalis. Acids and alkalis. We will discuss this one. How the 13th group elements reacts with the acids and alkalis. We will discuss now this one. Now, for this one, now just check. I will write again. Here for this one I will take another pen. Now just check here. Boron is not reacting with boron. There is no reaction with acids and alkalis. Even at moderate temperature. I will explain this one with taking rough paper. I will take rough paper first. Now just check. Here I am taking the rough paper. Now, if this one is the beaker and this one is another beaker. I took how many beakers? 2 beakers. This one is first beaker. This one is second beaker. One is filled with the acid and another one is filled with the base. One is filled with the acid, another one is filled with the base. In the first one, we are adding the boron. In the second one also, we are adding the boron. If you observe here, there is no reaction. There is no reaction at all. Means boron is not reacting with the acid, and also here also boron is not reacting with the base. Means boron is not reacting with acid, boron is not reacting with bases. Means with acids also no reaction, with bases also no reaction. Means boron is not reacting, that is boron no reaction with both acids and alkalis, even if you heat at a small temperature, at a moderate temperature. Right? Now what about others, sir? What about others? Others are reacting with acids and alkalis or not, right? Now just check. If you take aluminium, now just check. If this one is the beaker which is filled with the acid, and if this one is the another beaker which is also filled with the base, means one beaker is filled with the acid, another beaker is filled with the base. I took how many beakers? 2 beakers. One is filled with the acid, another one is filled with the base. This one is filled with the acid, this one is filled with the base. If you add aluminium, right, aluminium has the tendency to react with the acid, aluminium has the tendency to react with the base. Means this aluminium is reacting with acid, this aluminium is also reacting with the base. Reacting with the base means it is reacting with acid as well as base, and in all the cases, in both the cases, it is releasing H2 gas. Here also it is releasing H2 gas. Means when aluminium is reacting with the acid, it will releases H2 gas. When aluminium is reacting with the base, again it will releases the H2 gas. Those reactions we will discuss. Before that one, I will write here: aluminium reacts with both acids and alkalis, and releases the H2 gas. Now we will see the reactions, how it will react. That reactions we will see. For this one, I will take another paper. Sorry, here it is. Now just check how it will react. Now we will see. Now just check here for aluminium. For acids, reaction of aluminium with the acids, how it will react, we will see. Now for acids, now just check how it will react is. Now when this aluminium is added with the acid, let us take HCl. I will write balanced equation only. When this aluminium, 2 moles of aluminium reacted with the 6 moles of HCl, it will give Al plus 3 and 6Cl minus, means AlCl3, or you can write both as 2AlCl3, and it will releases the gas, hydrogen gas, that is 3H2. This gas is released, hydrogen gas is released. You can write 2Al, 1 Al charge is plus 3, means 1 Cl charge is 1 minus 1, right? Therefore the correct formula is AlCl3. You can write 2AlCl3 in place of writing separately 2Al plus 3, 6Cl minus, you can write 2AlCl3, and it will releases which gas? Hydrogen gas. This is the reaction of aluminium with acids, correct? Now we will go for the reaction of aluminium with base. How it will react with the base, we will see. Now for this one, now just check. Here it is. This aluminium, same 2 moles of aluminium, when reacted with the base, that is sodium hydroxide, right, in presence of water, right, for balancing 6 moles of water is required. Means when aluminium is reacted with the base, right, that is aqueous base, means more amount of water is there. 2 moles of Al reacts with the 2 moles of NaOH and 6 moles of water to form one complex. What is that complex? Is 2Na plus AlOH4 minus 1. Its name is, here it is outside sodium, right, sodium. Total how many hydroxides? 4. Tetra, 4 means tetra. What is that? Hydroxo aluminate, sodium tetrahydroxo aluminate. This is the name of this complex. This complex name is sodium tetrahydroxo aluminum, and also it will releases the hydrogen gas, that is 3 moles of hydrogen gas is released. Means when aluminium react with acid, it will releases the H2 gas. When aluminium reacts with the base, here it is base, again it is releasing the H2 gas. Means aluminium can react with both acid as well as base. When it is reacting with the acid, it is releasing dihydrogen gas. When it is reacting with the base, again it is releasing the dihydrogen gas. Means aluminium is reacting with both acid and aluminium is reacting with base. When this aluminium reacts with both acid and base, what is the nature of aluminium? Amphoteric nature. Which nature it is? Amphoteric nature. Means oxides and hydroxides are, aluminium are amphoteric in nature. This is the reaction of aluminium with acids and bases. This completes second reaction, right? Next we will go for the last one, reactivity towards the halogens. Last one, third one. Third one. This much of space is enough for me, right? Third one is reaction of 13th group elements with halogens. With halogens. Now just check here. 13th group elements. 13th group elements. If I take one 13th group element here it is rough paper. 13th group elements, that is E. What is the charge? What is the valency? Common valency is +3, right? Halogens, that is X, 17th group elements. Here it is 13th group elements, here it is 17th group elements. The valency is -1. Now what is the correct formula? Already I told how to write. E one time and X how many times? 3 times. Means what is the correct formula? EX3 is the correct formula. EX3 is correct formula. For example, if E is aluminium and X is Cl2, because halogens available as a diatomic X2, correct? Cl2, it will form AlCl3. Correct formula is EX3. Therefore AlCl3, fall balancing, you have to take 3 here, total 6 here, 2 means 2 moles of Al, right? 2 Al atoms, 2 Al atoms, right? Total 6 Cl atoms, 6 Cl atoms. Means this is the reaction. In this way, the 13th group elements reacts with the halogens. 13th group elements reacts with the halogens. That is only I am writing generally. Here it is EX3. EX3 is forming the compound is EX3. AlCl3, BCl3, correct, etc. Right? AlCl3, BCl3, etc. That is trihalides. 3 halogen atoms are there. Corresponding trihalides are formed. Tri means 3. Halogen atoms, 3 X groups are there, 3 halogen atoms. Here trichloride, 3 halogen, right? In this way trihalides are formed. That is only I am writing here. What I want to write is, just check here, when 13th group elements, when 13 group elements reacts with halogens, to form corresponding trihalides. One is not formed. What is that? The one trihalide is not formed. That is thallium triiodide. Correct? Here TlI3 is not formed. Except this one, all are formed. Except this one, all are formed. The reaction is general reaction. I will write general reaction. I want to write general is enough. That is when 2 moles of 13th group elements, that is in solid state, reacts with 3 moles of halogens, that is in gaseous state, it will form 2EX3, that is in solid state, right? Particular example, 2 moles of Al reacts with 3 moles of Cl2, gives rise to 2AlCl3. In this way, the 13th group elements reacts with the halogen. 13th group elements, E means 13th group elements reacts with the halogens to form the corresponding trihalides. This is the chemical reactivity of the 13th group elements with the halogens. Now this completes your chemical properties of the 13th group elements. Means what we have discussed? First we have discussed the, we have started with the, here it is, chemical properties of 13th group elements. In that we have discussed the oxidation state and trends. Oxidation state is all are shows +3 oxidation state, because all are having +3 oxidation state, because they are all having 3 valence electrons. They are all are shows the +3 oxidation state. Boron, aluminium, gallium, indium, thallium, all are having 3 valence electrons. If they lose or if they form the bonds with the other atoms, then the oxidation state is +3. Oxidation state is +3, right? When it will show the +1 effect, right? Only p electrons are involved in the bonding and s electrons are not involved in the bonding. That is inert pair effect. If there is an inert pair effect, then what happens? They will show the only +1 oxidation state. Now what is the order of stability for the +1 oxidation state? If thallium is more stable in the +1 oxidation state and the gallium is less stable in the +1 oxidation state in their compounds. In the thallium compounds, thallium +1 oxidation state more stable. In the gallium compounds, gallium in +1 oxidation state is less stable compared with the indium and thallium compounds, right? Now BCl3, BF3 are Lewis acids because they are ready to accept the electrons, that we have discussed. Next we have discussed about the how the BCl3 will accept the stability, sir, right? By gaining the electrons, by gaining the one lone pair of electrons or accepting the lone pair of electrons. How the AlCl3 will get the stability, sir? By forming the dimer. By forming the dimer means two AlCl3 will react and they form the dimer, that is bridge structure is formed, right? Next we have discussed about the reaction with air and nitrogen. Next also we have discussed about reaction with acids and alkalis. Next we have discussed the reaction with halogens. This is the reaction with air and nitrogen, and here it is the reaction with acids and alkalis. Reaction with acids and alkalis. And the last one we have discussed, that is reaction with halogens. Reaction with halogens, this we have studied. Now we will stop here only. We will discuss in the next class. Thank you.